And the sixth one is
Presentation.
presentation,
Then application.
then application. So this is a conceptual basis which have been defined by the OFC. Is it required to be followed the same layers by any of the equipment or any of the organization who have been defined these layers? So is it we required to be follow the 7 layers? The 7 layers is must and should need to be followed? Say yes or no. So this is a conceptual basis they have been given on that day. Is it required to be followed now also? The 7 layers at any time? Is it yes or no? It is no. It is not required. Suppose they have proposed this type of works is there. So application layer, they have to do perform what job? Presentation layer, what have to be done? Session layer, what have to be? So it is based upon my wish. Suppose if I develop a certain equipment, I need not to incorporate all these layers into my equipment itself. So to perform certain task, I can combine some layers together to perform a certain task and some other layers together to perform a certain task. Based upon that, some concept have been came into the existence which is called as TCP bar IP. What is this TCP bar IP? Mainly for computer networks, we use this TCP bar IP layers. So how many layers is there in the TCP bar IP computer networks? Can anybody can say? How many is there? TCP bar IP layers. How many layers? No.
4 layers.
Very good. 4 layers. So how why they have been reduced it to 4 layers? But OSA layer is telling that we should have 7 layers. It is a conceptual basis. It is a conceptual basis. It is not required to be followed. Only the 7 layers need to be implemented everywhere. Depending upon our requirement, I can increase the layers. Let I define my layers as my works as 8 or 9, or I can reduce it to 2 or 3 or 4. So based upon that, the TCP bar IP layers have been condensed to 4 layers. So the application, presentation and session have been combined together, and transport, network, data link and physical have been combined together in the TCP bar IP layer. Is it understood? In the same concept, for LTE communication also, this layers have been defined. We'll see in detail about these layers. Then the channel. So what is meant by a channel? What is meant by a channel? What is meant by a channel? Channel. Can anybody can say what is meant by a channel? Channel is a path on which the information can flow. Basically, these paths we used to create in analog. See here, if you see the architecture of LTE or GSM or some other architecture, so if you see at which part the information, that is the digital information, need to be converted into the analog form is, say if it is your mobile, maybe your user equipment, and from the user equipment to your BTS, or if it is in GSM BTS, if it is in a LTE, it is called as E node B. So here it is entirely what interface is being deployed. So the interface is air interface. Suppose if it is a air interface, how this communication can be assured? It can be assured only by analog conversion only, not the digital transmission. So during this analog transmission, the digital format which have been happened from the core network needs to be converted into the analog, and this analog transmission we required some physical channels of certain frequency. So here we need a necessity of these channels. So the channel is nothing but it is some information carrier, information flow between hardware protocol layers or different types of data which allow the transport around the different layers. So this is called as channel. Then what is mean by a plane? What is mean by a plane? What is mean by a plane? What is mean by plane? Plane. We have discussed about the layers. We have discussed about the protocols. We have discussed about the channels. What for these layers, protocols or channels need to be done? So what for these layers, protocols or channels? Up to now we have discussed. What for this needs to be mentioned? So these are all mainly for the communication from one entity to another entity. From one entity to, from one transmission entity to another transmission entity. So when they are transmitting, this plane will act a group which needs to be deployed the layer, protocol or channels that will be grouped together, and it is a concept of abstraction to perform an individual task. An individual task. So coming to this in normal network protocols or in the normal networks, we have three different types of planes. So can anybody can say what are the different types of planes we have in our network? Can anybody can say? What are the three different planes we have? Or 3 or 4 planes will be there in different architectures. So so let me explain in our network architecture. So one is called as data plane. Another one is control plane. And the third one is management plane. So these three planes can also be used in our LTE architecture also. So I think you have heard about this 5 terms. Now with this we'll go into the LTE protocol and we'll see the LTE architecture, how this protocol layers and channels and planes have been deployed in the LTE protocol stack or in the LTE architecture. We'll see in detail. So you all are aware about this. This is the architecture of LTE, isn't it? If you have any doubt, you can ask. This is the LTE architecture. Isn't it? So in the LTE architecture, the LTE entire architecture have been divided into two different parts. So one is called as universal terrestrial radio access network, and another one is the core network. That is the E means evolved packet core network, and evolved universal terrestrial radio network. And in this evolved universal terrestrial radio network, it consists of LTE equipment, multiple LTE, not only a single, so multiple LTE equipments. And from this LTE equipments, it is connected to the In GSM, we call it as BTS. But in the but in the LTE, the BSC and BTS have been combined together, and we are calling it as E node B. And between this one E node B to another E node B, there will be a connectivity, so that whenever the LTE equipment, that is the user equipment, is moving from one E node B to another E node B, there should be some soft handover. So based upon that, the connectivity is need to be required between the E node B to E node B. And if you see here, say in this diagram, the connectivity part, whatever the connectivity, the block diagrams is there, the connectivity have been differentiated by two different things. One is a solid connectivity of red, another one is a dotted connectivity of blue. Can you able to say, so what is this solid part and what is this dotted part? See, before any information flow, let me tell for a small example. If one person wants to communicate with another person, so when this person is not seeing him, suppose this person 1, person 2. If the person 2 is not seeing person 1, so if they are very nearer, okay, then he can say his name, say person number 2. Then the person number 2 will respond, and thereby the information whatever he wants to share, he will be shared. So that means the first thing is alerting the other person to whom the communication needs to be done. Is it understood? This alerting, we call it as, in a technical words, is called as signaling. Once this signaling messages have been exchanged between the two, then the data transmission can able to achieve between these two. Data transmission means the usual information that needs to be communicated between these two. Is it understood? So the first and foremost thing that needs to be done in this information transmission or data transmission or any other transmission, so the first part is signaling. And the second part is data transmission. Coming to our LTE architecture,